Alright, we're still doing trig power integrations, and this one is integral of sine squared times cosine to the fourth, which is where the two powers are both even. This is kind of like our worst case scenario, just the most work or the most confusing at times, aggravating. But we'll rewrite it. Sine squared is already squared, but we're going to write this other one as cosine squared squared. Okay, and in that we can do some replacing. We will replace sine squared with 1/2 minus 1/2 cosine of 2x and we'll replace cosine squared with 1/2 plus cosine of 2x, but that quantity is going to be squared. So we've got some squaring to do and some distributing. So let's take our time here and see what happens. So as I rewrite it, I think I'm going to go ahead and try to do the square part first. So I'm going to have the integral of, I'm going to leave the first part, 1/2 minus 1/2 cosine of 2x. And then the 1/2 plus, I left it out, 1/2 plus 1/2 cosine 2x. I'm going to go ahead and square that. So let me see what that will look like. It will look worse than the other one did. But 1/2 times 1/2 is 1/4 plus 1/4 cosine of 2x plus 1/4 cosine of 2x plus 1/4 cosine squared of 2x. So I doubled all those angles when I replaced them. I've got this long thing. Now it's nice that I can go ahead and combine these two middle terms. I could have done that while I was working. Let's just go ahead and do it right now. We're going to have a big old mess here. So we've got the integral of the quantity 1/2 minus 1/2 cosine of 2x times the quantity 1/4 plus 1/2 cosine of 2x plus 1/4 cosine squared of 2x. Alright, let's see where this goes. So we've got a lot of distributing to do here. So I'm going to take 1/2 from my first quantity and multiply it times everything in the second quantity. So that's going to give me 1/8 plus 1/4 cosine of 2x plus 1/8 cosine squared of 2x. And now I'm going to take the negative 1/2 cosine of 2x from the first quantity and multiply by everything in the second quantity. So that'll give me negative 1/8 cosine of 2x, negative 1/4 cosine squared of 2x, and then minus 1/8 cosine cubed of 2x. And let's see if anything combines before we get too far gone. So, integral. Okay, there's only one constant here. So that constant is the 1/8. So let's just pull it down. So we've got the integral of 1/8. And now let's see, what else do we have here? We've got a cosine of 2x, 1/4 of those. We've got a minus 1/8 cosine of 2x. So 1/4 minus 1/8 is plus 1/8 cosine of 2x. Then what do we have? We have a 1/8 cosine squared minus a 1/4 cosine squared. So 1/8 minus 1/4 is minus 1/8 cosine squared of 2x. And then lastly at the end we have minus 1/8 cosine cubed 2x. All this is dx. dx got lost somewhere in the mix here. So take a look at what we've got. We've got 4 different terms. So before I continue, the 1/8, that can easily be integrated to 1/8 x. I'm not going to do it just yet. The 1/8 cosine of 2x, that can easily be integrated. The minus 1/8 cosine squared of 2x, not easily integrated. So let's rewrite that. So let's bring what we have down so far. 1/8 plus 1/8 cosine of 2x. And then the minus 1/8 cosine squared of 2x. So we're going to replace cosine squared 2x using the formula we just used. And luckily it's close by over here. It's right here. Cosine squared of x equals 1/2 plus 1/2 cosine of 2x. So that will be 1/2 plus 1/2 cosine of doubling that angle will be 4x. Okay. And we're going to get a whole new angle there, but when we clean this up, we'll be able to work with it. And then minus 1/8 cosine cubed of 2x. That goes back to our situation 2, where we're going, oops, let's change our color here. Okay, caught up. So that's going to go back to minus 1/8. We're going to separate one cosine, so it'll be cosine of 2x. And it'll be times cosine squared of 2x. All this is dx. Now some of this we can integrate, but I'm just going to save it all till the end just so we don't have some parts integrated and some parts not. Okay, take your time with this. Pause, think. So bringing stuff down, we got 1/8 plus 1/8 cosine of 2x. Oh, no, nothing happened there. And then we'll have, when we distribute this negative 1/8, we'll have minus 1/16 minus 1/16 cosine of 4x. And if you take a look at everything that's here right now, yes, I can combine some things, but I can also integrate all of them. Okay, and then this last part over here, minus 1/8 cosine of 2x. And we're going to change, when we had an odd power for cosine, we separated one cosine, and then we wrote the remaining cosine squareds to a power, which is cosine squared to the first. And we're going to replace that cosine squared to the first with 1 minus sine squared. So we'll have 1 minus sine squared of 2x. Okay. One more step and I think I'll start integrating. So let's see here. I can combine the 1/8 and the 1/16, although it's not all that important. So that'll be an integral of 1/16 plus 1/8 cosine of 2x minus 1/16 cosine of 4x. So that's 2 different angles. It's not even in the angle we started with in the problem. And it'll be, let's do a u substitution here. Okay, for the last part, we're going to let u equal sine of 2x. So du equals 2 cosine 2x dx. So 1/2 du equals cosine of 2x dx. So let's just write this in a different color. Minus 1/8 the integral of 1/2 of 1 minus u squared du. So let me look at that. All this should be on one line. I just ran out of room there. So just making sure everything is okay. All this we got to integrate. Just part of it's in x and part of it's in u right now. We'll pause while I double check that. Okay, I feel good about that. Now, let's actually do some integrating. 1/16 becomes 1/16 x plus 1/8 cosine of 2x. The 1/8 is there. This is a u substitution. I'm not going to write it out, but sine of 2x, cosine goes to sine. This gives me 2x, but there'll be a times of 1/2 out front. Then we have minus 1/16. The cosine of 4x will go to the sine of 4x and put a 1/4 out front. And then my little u substitution over here, I'm going to pull this out and have 1 minus 1/16 out front. And it'll be times u minus 1/3 u cubed. And then this will be a big old plus c. So let's clean this up and rewrite it. I don't want to forget what my u was. Okay. So I don't know if there's going to be anything that combines here because all these things are very different. But let's see here. I've got 1/16 x plus 1/16 sine of 2x minus 1/64 sine of 4x. Then I'll have minus 1/16 and u was sine of 2x. That's interesting. Then I'll have plus 1/48 sine cubed of 2x plus c. So somehow in the midst of this, it looks like something cancels out. The 1/16 sine to the 2x minus the 1/16 sine of 2x. So, not about to run out of time, but run out of patience, I'm sure. 1/16 x minus 1/64 sine of 4x plus 1/48 sine cubed of 2x plus c. So if you took the derivative of this, you should get back to the thing we started with, which was, I believe, way up here. Sine squared cosine to the 4th. Now, sorry, let me get back down here to where we are. Now the reason it doesn't look anything like that is because we got new angles. Sorry. So if you took the derivative of these, that wouldn't be too hard. But you would have to use some trig identities to reduce the angles of 4x and 2x down to just x to make it look like the original problem. So taking a derivative of this and making it look like the original might even be more complicated than integrating it to where we are. Anyway, that's your worst case scenario unless you have something with higher powers that are both even.